All right, guys, so on the first question, it's asking you to determine which is a quadratic function. So remember, a quadratic function is something that's going to make a parabola shape when we graph it, but more importantly, the highest coefficient or the highest exponent power is always going to be x squared. Okay, so when you're looking at these, you're looking for something that the highest exponent is an x squared. And be careful with this one. Because even though it looks like it has an x squared, there's a 0 in front of it. And if I graph these in Desmos, so if you haven't accessed Desmos, remember it's going to be desmos.com/calculator. So if I graph the first one, y equals 2x to the third plus 2x squared minus 4. Remember, a quadratic is going to make a U shape. It's going to make a parabola. So in this case, it's not a quadratic, right? Because it's not making the appropriate shape. And the highest exponent is 3, and we want it to just be a squared. So you're going to look it through those and see which one has the highest exponent of 2. Now, number 2, the constant. So remember, a constant is going to be a number, okay, that does not have a variable with it. Okay, so again, you're going to look at your equation, you're going to decide which of those numbers, the 8, 7, and 6, would be a constant based on what we know to be the definition of a constant. On number 3, so the leading coefficient, okay, we just talked about a constant. Remember, it's going to be your number with no variable. And then a leading coefficient, okay, so a coefficient is going to be the number in front of your variable. Okay, and a leading one, that just means it's in front of the highest one. And then the last qualification that has to be, remember, it has to be a quadratic function, which means the highest exponent is going to be an x squared. Okay, number 4. So when simplified and written in standard form, which quadratic function is equivalent? So all we're going to do is we're going to combine your like terms here. And then the other way that we can check that is we can graph this in Desmos. And so I can graph the original one. And so I'm going to graph y equals 2 plus 7x. And again, I'm just going to replace that c with the x, minus 4x squared minus 3x plus 4, right? So that's going to be our original. And then I can graph the answer choices to see which one will overlap. So I'm going to do y is equal to negative 4x squared plus 4x plus 6. And what you'll notice is it's exactly the same graph, right? So if I hide it, there's my original one. And if I show it, it overlaps exactly. So that's how I know that's going to be the correct answer. So anytime they're asking you to match up those equations, go ahead and just graph them in Desmos to see which ones are equivalent. As we did on the other ones. And so again, remember your leading coefficient, right, is your number in front of your variable, okay, with the highest exponent, and then your constant is going to be the number that has no variable with it, right? It's not affected by any variable. So again, following those definitions. Okay, so on number 6, they're asking you what needs to be done to 5x to the third plus 2x squared plus 7x minus 3 in order to make it a quadratic function, because right now it's not a quadratic function. So we know that in order for it to be a quadratic function, the highest exponent has to be an x squared. And so looking at this, I know that the 5x to the third is what's going to be causing this not to be a quadratic function. So as you guys are looking through this, there are two different ways that we can fix this in order for us to not have this 5x to the third, right? We need to somehow get rid of it or change it some way so we can combine it with something so that my highest exponent is the x squared. On number 7, when they're asking you for the vertex, so the vertex is 0, 0, and remember the vertex is going to be your highest or your lowest point. So in this question, they're asking you which question or which quadratic graph has a highest or lowest point at 0, 0, which is also the origin on your coordinate graph. On number 8, so we're kind of looking at inputs and outputs. So they're asking you if you take an input of 2, which means I plug it in for my x, which is what they're doing here. All they've done is they've replaced the x's with the value of 2. And so all you have to do is just simplify this. So you can put that in the calculator. So that's saying 2 times 4 minus 3 times 2 plus 7. On number 9, so this is where graphing it in Desmos is going to help us. So what I would do is I would start by graphing the first answer choice. So my first answer choice is y equals 3x squared plus 2x minus 5. And then I would start looking at the table values. So I need to see at negative 2, 21. So if I look at my Desmos graph, you actually have the option to look at a graph. So you're going to click on this little edit list, and then you're just going to click on convert to table. And so all I want to do is I want to see, do these values match up? So notice this one is negative 2, 21, but on my Desmos graph, I have negative 2, 3. So that tells me that these do not match up. So I'm going to go ahead and eliminate this one. So you're going to go do and graph the rest of them and then see which one matches up with these x values exactly. On number 10, again, all we are doing is this notation is telling me that if x is equal to 5 and you take that and plug it into your equation of negative 2x squared plus 2x minus 3, what y value would I get? And so in this case, you can do this 2 different ways. You can graph this in Desmos. And so if I go and I graph so you'll graph y is equal to negative 2x squared plus 2x minus 3. And then again, remember we have the option to look at the table. So edit list and click on the table. And so you're looking for the x value to be 5. So all you have to do is just replace this 2 with a 5, and it's going to tell me what that output is. Okay, on number 11, same idea, except now we're just looking at the graph. So remember this notation right here is telling me if x is equal to negative 3, okay, based on this graph, what is the y value? So remember your x values are here, so negative 3 is going to be right there. So what y value will that match up with on the graph to create that point? Again, same idea with number 12. The only thing is when you guys graph this in Desmos, I would replace that a with an x. So I would do negative 2x squared minus 5x plus 4. Go ahead and graph it. And then remember, you're going to change that to the table value by going to the little settings, little wheel, and then selecting the table. And then seeing, okay, when x is equal to negative 3, what y value, what output does that give me? Okay, number 13, which function increases at the fastest rate between 0 and 8? So essentially what they're saying is which function grew the most. So if I'm going here from 0 to 8, okay, here it added from 2 to 18, so it added 16. Okay, so you're going to go through each one, okay, and you're going to see which one increased the most. On number 14, which one has a negative rate of change? So negative rate of change is going to be a negative slope, which means the graph is going to be going down. Okay, so they're asking you in this part of the graph, from where to where does the graph appear to be going down, meaning it has a negative rate of change. Now, same thing on number 15, which one shows a negative rate of change? Remember, negative means that the graph is decreasing in some way from 0 to 2. So, for example, if I look at just from 0 to 2 here, okay, the graph is going up, so this one has a positive rate of change, so that would not be correct. So again, just kind of looking at that piece right here on the graph from 0 to 2 and seeing which one of those graphs will have a negative rate of change, being a negative slope. Same idea on number 16, so negative rate of change is where they're asking you, where is that graph decreasing? From what x value to what x value is it going down? And then same idea with number 17 that we talked about earlier. Remember, a quadratic function, right, has to have a highest exponent of 2, meaning it has to have the highest exponent of x squared.